We walked through number 1 in class, so let's take a look at how we would set up and solve number 2. It's going to be really similar, but instead of trying to find dH, we're going to try and find dV. So we learned from the last one that what we need to do is find final velocity at the end of the ramp. So let's go right there and find that. Our net force again is equal to Fg parallel. So the mass of our box times acceleration equals mass times g times the sine of our angle. Angle is 30 degrees this time. So acceleration is equal to g times the sine of 30 degrees. Our acceleration for this problem is 4.91 meters per second squared, or 4.905 meters per second squared. Now that we have an acceleration, we can find the final velocity at the bottom of the ramp. We're going to use the kinematic equation as we did before to find that. So I know acceleration, so it's 2 times 4.905, or 91. Distance this time is 1 meter. Our initial velocity again is 0, so that's final velocity squared. Final velocity squared is 9.81. So our final velocity is 3.13 meters per second. Now I can go to the horizontal displacement equation. I know my horizontal displacement, and I know final velocity. Since I need the horizontal component of that initial velocity, I'm going to take 3.13 meters per second times the cosine of the angle, then times time. Time is the only one I don't know. Time is 0.922 seconds. That's the time our projectile is in the air. Now if we want to find dV, we're going to use the vertical displacement equation. Okay, so there's our dV equation. We know acceleration, it's acting down. Initial velocity is acting up, so we're going to make our downward negative, our upward positive. Now, since we have the correct sign on each side, we can find dV. And we get dV of 5.61 meters. That's the answer I gave you in class. For number 4, similar type of thing to number 3. It's just that our dV is not 0. Okay, dV for this problem is 0.75 meters. And it's acting down. Your initial velocity up is 10 meters per second. And we're looking for dH. Well, let's start with our dV and our dH equations. dH equals horizontal velocity, so that's 10 meters per second, times the cosine of my angle, times time. Two unknowns. Can't go much farther that way. dV okay, my dV is 0.75 meters down. Acceleration is down. Vertical velocity is going to be the velocity times the sine of the angle times time. And initial velocity is up. So I want to make sure I get my signs in correctly. So if I solve for sine of 25 times 10, I get 4.23. 1/2 times 9.81 is negative 4.905 because acceleration is acting down. dV is acting down. So I have it set up for a quadratic. Solve for time. I get 1.01 or negative 0.15 seconds. Only one positive time, so I can use that. I'm going to put it into my dH equation, and I can get horizontal displacement. So we answered the first part. How far away from the ledge can you land? What is your velocity? That's a little bit more challenging. Let's take a look at how we'd set that up. We need the velocity in the horizontal direction, and we need the velocity in the vertical direction. Velocity in the horizontal direction is constant. That's the easy one. Let's do that first. Horizontal velocity component is 9.06 meters per second. Final velocity in the vertical direction, I'm going to use a kinematic 2AD equals VF squared minus VI squared. And both of my velocities are going to be vertical velocities. So I'm going to say 2, my acceleration vertically is 9.81 meters per second. dV, vertical displacement, is 0.75. Final velocity, vertical, that's what I'm looking for. Initial velocity, vertical, I found that here. And I got 4.23, which gets squared. So if I do the math, I get 32.61. So final velocity in the vertical direction, 5.71 meters per second. Okay, so let's draw a diagram that shows that. So I have a horizontal velocity of 9.06 meters per second. I have a vertical velocity of 5.71 meters per second. Those are the components of my velocity when I hit the water. So my velocity, direction, and value, as I did before, is going to be the hypotenuse of the right triangle this creates. So my final velocity is the hypotenuse. So I do Pythagorean theorem. I get a final velocity of 10.71 meters per second, which is larger than my initial velocity because I've traveled farther down. I'm lower than where I started, so I'm going faster than what I was going when I started. So this takes you through number 2 and number 4 on that practice sheet, and so now you've got a good idea of how to solve problems like this.